These final topics that we're going to cover in this integration review, I'm going to do super fast because you just took a test on these topics. Hopefully they're pretty fresh in your mind still. Solving differential equations. That means to find the original function. Given some differential equation, dy dx equals 4x squared plus 7, given the slope of the function, find the original function. You can just do this by anti-differentiating. So if dy dx equals 4x squared plus 7, then y had to equal 4/3 x cubed plus 7x plus some c. You can differentiate that quickly to see that it is the derivative. Dy dx does equal 4x squared plus 7. To find c, we plug in the point. We know y of 0 equals 9. So 4/3 goes to 0, 4/3 x cubed goes to 0, 7x goes to 0. And I'm just left with the c. So c equals 9, and my final answer is that y equals 4/3 x cubed plus 7x plus 9. There's the solution to my differential equation. Sometimes, though, we don't know how to solve the differential equation, which is why Euler's method is a great way to approximate the solution to a differential equation. I'm actually not going to work this one out for you because Euler's method is the same procedure every time. If you're unsure about how to do it, go back and look at your notes. I would pause the video now and just try this one on your own, and I'll put the answer up after you unpause the video. So using delta x equals 0.5, that means we're taking 2 steps, and your final answer should be that f of 1 is approximately 4.25. We did solving differential equations with slope fields, Euler's method, and separation of variables. But because slope fields and separation of variables are not part of this review, you can guess that they're not going to be a big part of your final exam. We are going to move now into the second part of your previous test, which is area and volume. We'd already talked about area between a curve and the x-axis being integration, but we talked about what happens when you have area between 2 curves. And we said you just integrate the distance between them, which is top minus bottom. In this case, our function f is on top, our function g is on the bottom, so we're going to integrate f minus g between wherever they intersect, which is a and b. Don't forget to find intersection points. You can set your function equal to each other, or if you're using a calculator, you can graph and intersect them using your graphing calculator. So again, to find that area, we just integrate top minus bottom from a to b. We can also do volumes of known cross sections. So say we take some curve f, and we know that cross sections, let's put it, from a to some value of b. So we have this area, cross sections perpendicular to the x-axis are squares. That means that we're putting a square right there, pulling it out of the board. And then we're putting another square right here, pulling it out of the board. Infinitely skinny squares. We know that the side length of each square is just my function value. It's just the height of that function. And to find volume, you can integrate that cross-sectional area, meaning that the volume is just the integral from a to b of f of x squared dx. I'll tell you now that just like on your test, the cross-sectional area will either be a square or a semicircle. It's not going to be anything really difficult that you have to memorize, like a triangle. And then finally, volumes of revolution. If you remember, we have both washers and disks. Disks are easier when your area is flush against the axis. I'm going to tell you now, you do not have washers on your final exam, you just have disks. So say that we have, again, the same area from A to B. But instead of stacking squares on top of this area, we're rotating it around the x-axis. If we're rotating it around the x-axis, there is the radius of that disk that's formed when I rotate around. Again, to find volume, you integrate your cross-sectional area. Here, our cross-sectional area is a circle, so we're going to integrate pi r squared. Our radius here is just f of x, so we're just integrating pi radius squared. I apologize if I flew through these past topics, but because this is the information that you've seen most recently, hopefully you feel pretty good about it for your final exam.